All right, so in this video, we're going to take a look at solving linear and nonlinear systems. So to solve a system means to find the points at which the two graphs intersect. In these problems, there will be a linear function and a quadratic function, a parabola. So generally, there's going to be two places at which the two graphs will cross, meaning two solutions. There can be one solution. So here's two solutions. You have your parabola and it crosses over. You can have one solution if you have this situation down here where the parabola, if the vertex of the parabola is where the two functions intersect, so right at the vertex is where they intersect. Or you can have no solutions if by chance they just did not cross at all. So the line was graphed, either under or above if it was a downward facing parabola. So they just don't intersect. The method used in these problems is substitution, as both equations are going to be equal to y or can easily be made to equal y. So you'll see that on the next page when I show you the equation. Once substitution has been used, then the problem needs to be simplified and factored. In factored form, the solutions can be found by setting each factor equal to 0 and solving. This will provide the x-coordinate for each solution. And now we're going to plug back in the x value to the linear equation to find its corresponding y-coordinate. So very similar to what we were doing before when we were trying to find the solution to two lines, but now we're going to find the solution to a quadratic and a linear. All right, so here's the two equations. We're going to practice it twice. So we have a quadratic and we have a linear. Okay, so I know it's x squared, that's quadratic. It's just x, that's linear. Okay, so when we substitute them together, what I mean is since they both equal y, we want to know when y is going to be exactly the same. So we're going to set them equal to each other because I want y to equal y. Now, y doesn't always equal y, right? We can have a whole lot of different y coordinates on the graph, but we want to know for this situation, when does y equal y? So that's why we're setting them equal to each other. Okay, so now we're going to bring everything over to the one side. So I'm going to subtract 6x and 7 from both sides. So I end up with 0 over here. X squared is going to drop down. 7x minus 6x is 1. And negative 5 minus 7, well, that's going to give me negative 12. So now I'm going to factor this, and there was a whole lot of different ways of factoring. I know I've done this in my classes a lot of different ways because you can factor by creating two binomials and doing it the way that I'm going to show you on the screen. I've also shown students how to do the box method because it's kind of a reverse of the multiplying method. So there's a lot of different ways to do this, but I'll go ahead and use binomials. So the only way to get x squared is to do x times x. So that's definitely a nice easy one to do. 12, there's a few more options here. I can do 1 times 12, 2 times 6, 3 times 4. You do want to keep in mind, excuse me, that we have a positive and a negative. So the only way to get a positive and a negative means that I have a positive and a negative, okay? Because that's the only way to get a negative at the end when I multiplied. And I can get a positive from that if the bigger number was positive when I subtracted the two. When I subtract a positive and a negative, or when I add them, I should say it that way. So just keep in mind, if they're both positive, then both of these would be positive. If it was a negative and then a positive, they'd both be negative. Because the only way to get a negative a positive on the end with a negative in the middle would be a negative times a negative. Okay, so you want to pay attention to, how do I get those signs? Okay, so since I know it's going to be positive and negative, I want to subtract to get to 1. Well, that's going to be 3 minus 4, right? That's going to get me 1. I want specifically positive 1, so I know I want my bigger number to be positive and my smaller number to be negative. So it's 4 minus 3 is positive 1. All right, so now I'm going to set them equal to 0. I'm going to subtract 4 from both sides, so I have x equals negative 4. Add 3 to both sides, so x equals 3. Okay, so these are just the x coordinates. Now I have to go and take the linear function, and I need to plug these in to find the corresponding y coordinates. So I've plugged in negative 4 for the first one and positive 3 for the second one. So I'm going to have 6 times negative 4, and I get negative 24, plus 7, and I get negative 17 here. So now I'm going to go through this one. 6 times 3 is 18, plus 7, and I get 25. and then -4 and -17, that's my first one, and 3 and 25, that's my second solution. So make sure you get the whole solution. You can't just type in the x coordinates and be done. You have to have the whole coordinate in order to finish this one. All right, so let's go ahead and do one more of these. So we have our second set of system equations, and I'm going to set them equal to y. Again, I want to know when is y the same. So now we're going to move everything over to the right side again. So I'm going to add 4x, I'm going to add 21 to both sides so that I have 0 over here. 7 plus 4 is going to give me 11, and -3 plus 21 is going to get me positive 18. So now I can factor this, and again, the only way to get x squared is x and x. 18 does have some more options because it's all plus plus. You can see I have plus and plus in here. So I'm going to add to get 11. So my two options there, or my only option there, is 2 and 9. So it doesn't matter which one I put in which spot. That's not a big deal because they're both positive. So I have x plus 2 equals 0, x plus 9 equals 0. I'm going to solve. So I'm going to subtract 2 from both sides, and I get x equals -2. I'm going to subtract 9 from both sides. I get x equals -9. All right, so again, this is the x coordinate. So I'm going to go to my y, or my linear equation, and I'm going to plug this in. And I'm using the linear one simply because it's a little easier. I don't have to square and then multiply and then combine. I can just multiply and either add or subtract whatever's going on there. It's just the simpler one to use, I think. So -4 times -2, I get positive 8, minus 21 is -13. So I have -4 times -9, which is going to give me positive 36, minus 21 gets me 15. So my two solutions are -2 and -13, and -9 and 15. And of course, it does matter which two you put together because -2 definitely goes with -13. That's what I got when I plugged in -2. So, obviously those need to stay grouped together. And 9 is what I plugged in to get 15. So that is how you solve a system of equations with a quadratic and a linear. Hope that helped, and I'll see you in the next video.